Now if you see all these three proposals, you will find that in such condition, if you try to measure the variances, sometimes you may have a wrong conclusion. You find here is that the values vary to a great extent. If you compare proposal A and B and then compare proposal C, the values are quite different. In first two situations, we are dealing in hundreds or maybe even thousands, whereas in proposal C, we have values in lakhs or hundreds of thousands. So in such situation, sigma square doesn't give us the correct picture. So under such situations, we use a term called coefficient of variation, CV. Now I will show you how to calculate CV. Before that, you can calculate the expected value of demand for proposal C in your usual manner. It is given as 980,000 multiplied by 0.2 plus 1,000,000 multiplied by 0.6 plus 1,020,000 multiplied by 0.2. What you get here is the expected value of 1,000,000. The variance corresponding to alternative C is, you can see, it's quite high, and the standard deviation, which is the square root of under root of variance, is 12,649. So if you take the criteria of variance, you may make an error of discarding this option, but that may be wrong. See, just try to understand what we are saying. In first case, we had a variance of some value. In second case, we had a variance of some value. And in third case, we are getting a very large variance. For example, for proposal A, the variance was 63 into 63. So the standard deviation we got was 63. For proposal B, we got a standard deviation of 379. Now compare this with proposal C's standard deviation. We are getting a value of 12,649. So if we are not aware of the concept of coefficient of variation, we will think that proposal C is too risky. But in real situation, you will find that this is not so, because we are dealing with large numbers compared to other two proposals. In proposal A and B, we were talking in hundreds and thousands. In proposal C, we were talking in terms of hundreds of thousands. So under such situations, you try to judge the risk with coefficient of variation. That is defined by standard deviation divided by expected value. So coefficient of variation is nothing but sigma divided by expected value, where sigma is your standard deviation. So if you calculate using CV, you will find that proposal C is not that bad. So whenever you find that there is a large variation in the predicted values, when there is a large variation in expected values, you should not use the variance and standard deviation alone. You should calculate the ratio coefficient of variation, and then only you should make a decision. So what we are going to do is we are going to stop at this particular point, and in next class we will take up the balance ones, right? And once I take your doubts, I will request my people to replay this particular DVD for you, and so that you can understand whatever you have missed. So, you have any doubt whatever we have covered till now? Yes, technology class, you have any doubt?
No doubt.
So, can we continue further? Or you want to get the replay?
Continue.
Okay. So, in this class, till now we have covered different aspects of expected value for discrete distribution. We have found out the variances, the standard deviation, and the coefficient of variation. Now, we will see some of the aspects, some more concepts which help us in making our decisions. So, we are going to learn two such methods which helps us in deciding a particular course of action. That means in evaluating the alternatives. First one is known as investment risk profile. It is known as investment risk profiles, and then we will try to cover acceptable investment diagram. These two are quite frequently used for evaluation of expected values. Now, in addition to these two, we have auxiliary decision criteria also, and there are three things in that. One based on variance, second based on most probable future, and then third one is aspiration level. Now, we will take each one of them one by one, and we will try to illustrate all these concepts using some small illustrations, some simple illustrations. So, first I give you the example for investment risk profile, and for this you can note down this particular problem. In this problem, I have assumed that the investment required at the beginning is $200,000. Initial cost is $200,000. Interest rate I have assumed to be 9%. Now, the expected annual returns is 50,000 with a probability value of 0.3, 100,000 with a probability value of 0.5, and 125,000 with a probability value of 0.2. Now, the duration of returns, it could be 2 years, 3 years, 4 years, and 5 years. Right? Now, this is what has been shown in the form of a decision diagram or decision tree. The problem which was shown to you in previous slide has been converted into a decision tree like this. So, as you can see from this particular slide, at time t is equal to 0, you have to invest $200,000. The annual return could be 50,000, 100,000, 125,000. The associated probabilities are given inside the node 0.1, 0.7, and 0.2. Now, the duration of returns could be 2 years, 3 years, 4 years, or 5 years, and the associated probabilities are also known to us: 0.2, 0.2, 0.5, and 0.1. Likewise, for all the cases, we have got the similar probability values. The minimum attractive rate of return given is 9%. So, what we are given here is uncertainties involved not only for the returns, the value of return, but also the duration of return. We are not sure whether the 50,000 value we are going to get for 2 years, 3 years, 4 years, or 5 years. Similarly, we do not know whether the return of 100,000 I am going to get for 2 years, 3 years, 4 years, or 5 years. So, now we are dealing with the uncertainties at two levels. Now, what we do in this is, like previous example, we take each of these paths individually and then try to calculate the joint probability. For example, if you take the first path, that means getting an annual return of 50,000 for 2 years period. Suppose I am interested in finding this probability. It would be the product of 0.1 and 0.2. That means the probability that I am going to get an annual return of 50,000 for next 2 years is given by 0.1 into 0.2, which is 0.02. Likewise, for each of the 12 paths, you can notice the number of paths in this particular example is going to be 12. So, for each of the 12 paths, I am going to calculate the joint probability. Not only that, I am also going to calculate the net present value for each of the different paths. So, two things. For each of the 12 paths, I am going to calculate the joint probability, and for each of these paths, I am going to calculate the net present value. Why we are doing this? Because we are assuming that the return and the amount of return, that is duration of return as well as the amount of return, they are dependent on each other. Now, if I just show you on this piece of paper, the first path is something like this. This is minus 200,000. Return is 50,000. Probability is 0.1. Here it is 0.2. And duration of return is 2 years. So, the probability, joint probability is going to be joint probability is 0.1 multiplied by 0.2, which is 0.02. Now, this first step is over. I have to calculate the net present value now. So, I can do it by making this as a simple cash flow diagram, minus 200,000 and a return of 50,000 for 2 years. 50,000 for 2 years. So, if you try to calculate this at an interest rate of 9%, you will get a value of minus 112,045. This is nothing but the net present worth of path 1. Likewise, I am going to calculate the net present worth of each of my 12 paths. Once I have got these net present worth value, I am going to multiply them with joint probability. So, if you see this particular slide, for path 1 I have calculated minus 112,045, for path 2 minus 73,436. Likewise, for all the 12 paths it has been calculated. Now, in the last column you find the weighted outcome, which is nothing but the product of column 1 and column 2. So, there are some more calculations in the next slide. The sum of joint probability, you will notice that it is coming to be 1, it has to be. And the weighted outcome sum is coming to be 58,022. Now till this point it is clear, we have not studied anything new. This type of problem we did in today's class itself. Now using this set of information, we are going to draw investment risk profile, which will help a decision maker in arriving at a decision. So for this what we do is, we try to write the probability values and the weighted outcome in ascending order. So if you see the right side of it, this part, these are the weighted outcome, rather these are the net outcome, net present worth for each of the paths arranged in ascending order, and the associated probability values are given in the next column. Now what we do is, we take a cumulative probability values. For example, minus 73,436. Corresponding cumulative probability value is coming from here, 0.06 plus 0.06. That is coming to be 0.12. Likewise for this, net present worth, probability value is 0.27, cumulative probability I am talking of. So this type of calculation is performed. And then we draw the investment risk profile like this, where at x axis we have net present worth and on y axis we have cumulative probability values. So this particular line, which is shown in the blue, is nothing but the investment risk profile. Now you can find that this risk profile has been divided it into two parts. One is showing you the loss and another is showing you the profit. How did we get this line? This line is drawn at point 0. So corresponding to net present worth of 0, you are drawing this vertical line, and that line we are extending it to get the corresponding cumulative probability values. So what you find in this particular example is that there is about 40% chance. Cumulative probability value, you can see it is slightly more than 0.4. There is about 40% chance that this particular investment option may return you a loss, whereas there is a 60% chance or slightly less than 60% chance that this particular investment option may give you profitable returns or positive returns. So once you have been able to develop a risk profile like this, arriving at a decision is not a difficult task. Now what will be the ultimate decision is again dependent on the person who is making the decision. Somebody may think 40% chance of making loss as too less. Somebody may think as a too high a chance to compromise on. So finally what you see is that although these tools are useful for making decision, ultimate responsibility rests on the person making the decision. So this is as far as investment risk profile is concerned. In next class, I will tell you about acceptable investment diagram and auxiliary decision criterias, which further helps us in making decision when we are concerned with different types of risks or under risk situations. So, at this point of time I would like to close this lecture and I would like to take your doubts, please. Yes, technology class, you have any doubt? I believe you missed some portion of the lecture today.
No doubt, but
You want to copy something?
the DVD is measure of bias. Would you repeat it, please?
You want to repeat the DVD?
Yeah. Starting from measure of bias.
From major?
Or
From here?
variation.
From here?
Measure of variation.
Okay, from here. So, I will request them to replay it for you. Thank you and good night.
Thank you.
Uh-huh.
Last part one. Oh. Net profit per investment.
Net profit and
जो net profit diagram
net investment risk profile.
investment risk profile उसके previous slide
You want that?
ये calculation होना चाहिए previous
I will just request them to replay it for you. उनको बोल देंगे ऊपर में यहाँ से रिपीट कर दें मेजर ऑफ वेरिएशन से ये कर रहे हैं शायद आई थिंक दे आर डूइंग